This is the Lex Solar Wind Professional, our experiment system for the study of wind power at the level of vocational education. For safety and easy handling of the equipment, the components are clearly laid out in a practical case. We would like to perform an exemplary experiment and with the components, investigate the dependence the pitch angle has on the open circuit voltage and the speed of a model of a wind turbine. The open circuit voltage is an important parameter of voltage sources as it refers to the maximum voltage. For this experiment we need the professional base unit with the smart control components AV module and power module, the wind machine, the wind turbine with module plate, three blades, the hubs for the three blades with different angles, the hub cover, the rotational speed sensor, a power supply, and cables and short circuit plugs. Now we have all the equipment together to assemble the unit. First we need the base unit. It has a ground line and provides slots for up to 4 modules that can be connected in series or parallel. The most important component for the experiment is the model of the wind turbine. For this, we first attach the wind turbine to the module plate and then these two elements onto the base unit. To complete our model, we then have to assemble the rotor. For this, we choose the hub with the 25-degree pitch angle. We put this in front of us, turned around on the table. Then we put the 3 rotor blades in the hub. They have a rounded surface that when laid down needs to face up. The 3 blades are now in the hub and the hub can be closed finally with the cover for the 3 blades. Since we want to measure the rotational speed later and the speed is measured by a laser, we have attached a reflective foil to the 3 rotor blades. This makes it possible that enough laser light is reflected and accurate readings can be recorded. For our setup, we now attach the rotor to the wind generator. To provide controlled wind conditions for the experiment, we use the wind machine. We put this on the base unit first. We can supply the wind machine with power via the power module. When connecting the power module, it is important to pay attention to the polarity, otherwise the wind machine won't function. The wind speed can now be determined by the voltage at the power module. For our experiment, we are using a voltage of 12 volts. To measure the open circuit voltage, we connect our model to the AV module. This module measures voltage and current. A short circuit plug connects the AV module and the wind turbine model. After switching on the AV module, our setup is ready for implementation. Next, we turn on the power module and the wind turbine and wait until the open circuit voltage remains constant. In this case, the wind rotor assumed a constant rotational speed. The open circuit voltage amounts to 5.3 volts. Then we measure the rotational speed. Here we make sure that the measuring device is positioned directly on the reflective foil and the angle of the laser light on the foil is low. The measured value is about 20,000 revolutions per minute. This is, however, initially divided by 3 and rounded appropriately, since a complete revolution occurs only when all 3 rotor blades have completed a cycle. The real value approximately amounts to 6,650 revolutions per minute. For another measurement, we now change the pitch angle and switch the hub. For this, we turn off the wind machine and remove the rotor from the model. Then we press the wind rotor first with the tip on the table to open the hub. The new rotor is constructed in the same way as the previous one. For our second measurement, we take a pitch angle of 50 degrees. Once it is ready, we put it back on the wind generator. Then we start the wind machine and carry out the measurement in the same way as before. The voltage is now 1.67 volts. The measured speed is 6,000, which is in reality 2,000 revolutions per minute. Based on the measurements, we have confirmed that with a pitch angle of 50 degrees, the open circuit voltage and the revolution speed is less than that with a pitch angle of 25 degrees. The other blade angles can be used for further measurements. In addition to this experiment, more than 20 other experiments can be carried out on wind power generation with the Lex Solar Wind Professional. In the accompanying instruction manual, you can find different experimental setups and additionally, in the experiment handbook, possible evaluation proposals. For example, in the case are additional blade designs and a hub for 4 rotor blades. This allows for the examination of the open circuit voltage and the rotational speed of the wind turbines with 2 and 4 rotor blades or another blade profile. If consumers are needed for an experiment, there is a motor module, a potentiometer, and several ohmic resistances ready. With the potentiometer, it is also possible to measure and compare the IV characteristics of the DC wind generator with different rotor settings. Another measuring tool is the anemometer. It allows, for example, to determine the loss of wind speed after flowing past the rotor blades. In addition to the model of a conventional wind turbine, a Savonius rotor is also supplied in the case. It makes it possible to compare the 2 technologies and to identify advantages and disadvantages. On the accompanying CD are experiment instructions and background information for teachers and include experimental protocols for the students. We wish you lots of fun experimenting.